right, this is getting exciting. We, together, found these equations that model our constrained optimization problem, the problem where Otto Toyum is trying to make the best use of his limited resources. And we know that if we just graph these, we can look for points of intersection to find the solution to our system of equations. The problem we encountered before is that we didn't know how to graph lines in standard form. And so we converted these equations into slope-intercept form. And you're here because you correctly converted this equation that describes tanks. So great work. What we have to do now is use these three slope-intercept equations to graph our three lines and then figure out the optimal solution, that one combination that makes Otto Toyum the most money he can make in sales. I guess profit, sales is a little different. In any case, let's go to graphing these because we already have practice graphing system of equations in slope-intercept form. So let's get into it. I'm going to hop myself over to Desmos, working on the same graph that we worked on videos and videos ago when we had not the best method yet for solving this system. Let me get rid of that work that we did. And let's talk about our wheels line. We know the line that describes the way we consume wheels is y equals negative 2/3 x plus 6. So I'm going to put my y-intercept here on 6. And my slope of negative 2/3 tells me that I need to go down 2 numbers and then to the right 3 to find the next point that's on this line. So I'm going to go down to 5, down to 4, and now my x is going to go 1, 2, 3. There's my second point. I can keep following this pattern. My y is going to go from 4 to 3 to 2, and x goes up to 4, 5, 6. And we have another point that's on our line. And we have space to keep doing this work, so I'm going to keep doing this work. Y is going to go from 2 to 1 to 0. X goes from 6, 7, 8, 9. And we have these 4 points that we can use to draw this line. So what are you going to do? You're going to find your graph paper that has all of your dots on it, and you're going to use your slope and your y-intercept to plot these points. And you'll connect those points with a line, and when you're done, you should have a line that looks just like mine does. Pause if you need to. I'm going to plot the line that talks about our seats. And just to refresh myself, we know that seats is modeled with the line y equals negative 2x plus 14. Y equals negative 2x plus 14 is what we're working with. And so my y-intercept will be up here. Very nice. And the instructions tell us go down 2 over 1. Down 2 over 1. That's what our negative 2 slope indicates. So 14, 13, 12 over to 1. 11, 10 over to 2. 9, 8 over to 3. 7, 6 over to 5. 5, 4 over to 6. Oh, I miscounted. I'm here at 4, 5. Do as I do, not as I say. When is the last time you heard that? I'm going to go down 4, 3, 2, over to 6. And now from 6, 2, down to 7, 0. And I have as many points as I can fit in my first quadrant. So I connect them with this straight line. Our last equation models how we consume our gas tanks, and that's y equals negative 1/3 x plus 5. Let me double check my work. I don't want to make a mistake. Y equals negative 1/3 x plus 5. Excellent. So let's start. Here's my y-intercept, and I'll go down 1 to the right 3. Down 1 to the right 3. Down 1 to the right 3. And I've run out of space. So I'm going to connect my 4 points with a straight line. And I'm going to keep moving past that straight line and take that going along the x-axis there. And so here is the graph of our system of equations. What I'm going to do is type these into Desmos, double check my work, but your work should be correct if you're following along. And we're going to get ourselves some nice clean lines. 4x plus 6y equals 36. 2x plus y equals 14. And x plus 3y equals 15. Once I clear this work up, let's take a look at that. Desmos gave us the same lines that we figured out with our slope-intercept form. And now we know that intersecting points are solutions to systems of equations. We have, look at this, an intersection here, and an intersection here, and an intersection here. Let's look at these points. This is 3, 4. This is 6, 2. And I'll tell you, right now I don't really care about this point. You tell me why I don't. I'll see you in the next one.